This is part 2 of section 9.5. We've just talked about a vertical shift, and now we're going to talk about a horizontal shift. Now, I had the vertical shift labeled as an outside. I have the horizontal shift labeled as an inside. You should understand in a second what I mean by that. The graph of f of x is equal to x minus h squared is a parabola with the same shape as the graph of x squared, and I'm going to go on in just a second. What I mean by inside and outside, notice here that the change from x squared to this is this h, and the h is inside of the square. Compare that to the vertical shift where the change was outside of the square. That actually ends up being really important whether something is inside the square or outside of the square as to which direction you move. We hit this very hard with other kinds of graphs in college algebra. Okay? So this change is inside the square, and that's what makes this a horizontal shift as opposed to a vertical shift. Okay? The parabola shifts horizontally h units to the right if h is a positive number. Okay? And then we're going to move basically the absolute value of h units to the left if h is negative, and the vertex is the point h0. The vertex on the other one was 0k. Okay? There's a big warning here. This shift seems very, very backwards, and it's all because this is a minus sign in here. Okay? If you have a plus sign, you're going to shift left. If you have a minus sign, you'll shift right. Okay? So let's just take an example, and I'll show you what we mean by that. Okay, so let's say our x or our h is, I don't know, 12. If I take a 12 and plug it in right here, that's going to look like x minus 12 squared. My h was a positive number, but there's a minus sign in here. Okay, so this would be a move to the right. If my h is a negative 12, and I plug it in here, that's going to be x minus a negative 12 squared, which simplifies to x plus 12 squared. And this, even though it looks like a plus, my h is negative, and I'm going to be moving to the left. So mainly you need to remember that this seems very backwards. Okay? So let's talk about an example. I want to graph f of x is equal to x minus 2 squared. Okay? So the difference between this and x squared is this 2, and it's inside the square, so I'm either going to be moving left or right. My h value, that's a 2, so I know I'm either moving 2 units left or 2 units right. Remember, if you have a minus sign, you're moving right because this seems backwards. So I'm going to take this and I'm going to move it to the right 2 units. Now this works exactly the same way as the other one did. Okay, if we take our basic graph and put it on here, that's our original, and we're going to take this and we're going to shift it 2 units to the right, and that's going to be our new graph. That's all that's going on here. Okay. So just like before, I'm going to ghost my original 5 points. So I can think about moving each of these to the right 2 units. Now some of these, when I move them, they're going to overlap with other points, but that doesn't matter. If I take this and I move it right 2, it's here. This one goes here. This one goes here. This one ends up on top of this other point. That's okay. And move this one right 2, and it goes here. So your new graph looks something like this. Okay? So let's try a different one here. If I have f of x is equal to x plus 1 squared. Okay, so the change here is a 1. And it is inside the square, so I know I'm going to be moving 1 unit either left or right. Now remember that this seems backwards, so in this case, my h is equal to negative 1 because this is a plus sign. It's a negative number, so we're going to be moving left 1 unit. Okay, and this is going to work exactly the same way as all the others. You start off with your original graph, and we're going to take this and we're going to shift it just left 1 unit, and that's our new graph. Okay, so ghost your original points. And then move each of them left 1 unit. And you have your new graph. Okay? Now I do want to take a second and say that you can have a combination of shifts. I don't have this example exactly written down for us to talk about, but let's say you had f of x equal to, let's say, x minus 2 squared plus 3. Okay? This is inside the square, so this is going to be our horizontal shift. This is a minus, so my h value is positive. This says I'm going to go right 2. This is outside, so it's our vertical shift, and this one seems normal. Vertical sheets seem normal. This is positive, so I'm going to go up 3. Okay, I'm going to use this same grid here just to show you. But what we would do is we need to go right 2 and then up 3. That would be our new graph right there. Okay, or you could go up 3, left, or right 2, and you're going to end up in exactly the same place. Okay, all right. So the graph, here's some general stuff. The graph of the quadratic function defined by this. Notice there's a number in front. I had a 1 right here. Okay, the graph of the quadratic function defined by f of x is equal to a times x minus h squared plus k, where a is not equal to 0, is a parabola with a vertex hk. This is going to be like a multiple shift like I just showed you. Okay, and the vertical line x equals h is the axis of symmetry. Okay, now what we mean by the axis of symmetry, I pointed out that on our original graph, the y-axis was where we were symmetrical. Well, every parabola is also symmetrical, and it's going to be symmetrical about the vertical line that goes through the vertex. So if you imagine me drawing this in right here, okay, this is what we call the axis of symmetry. Okay. Now, if you're asked for the axis of symmetry, it has to be x equals h. This is the equation of a line. If you leave off the x equals, it's going to be wrong. You cannot tell me that the axis of symmetry in this case is -1, because it's not. Okay? We're going to get a lot more into all of this. Okay? Now, this number in front can change a bunch of things. Okay? Our graph is going to open upward if a is a positive number. A in every case we've worked so far has been a +1, and every graph has been this basic shape. But if the number in front is a negative, it flips the graph upside down. So it's going to look more like that. It opens up if the number is positive, and it opens down if the number is negative. Okay, now this number in front can also make our graph change from, this basic shape to more like this, making it a little bit wider. Or it could also make it very narrow. Okay, that multiplier does change the basic shape of the graph. Okay, so this is going to mean there's actually more going on by, you're more than just shifting in this case. Okay, that multiplier changes things. Okay, but the graph is going to be wider than our normal graph if the number value is between 0 and 1, ignoring the sign. The sign tells you whether it opens up or down. Just the basic number tells you whether it's going to be wider or narrower. So if this multiplier is a 1 or a -1, ignoring sign, this number, if it's going to be wider, is maybe 1/2. It's some number between 0 and 1. It's going to be narrower if the multiplier is larger than 1. So the multiplier here might be 3. Okay? What we're going to be asked to do is we're going to graph 1, and then after that we're just going to talk through what we know about these graphs. Okay? So, keep this in mind. This first problem, We want to find the vertex, the axis of symmetry, how it opens, and whether the function is wider, narrower, or the same as the graph of f of x equals x squared. And we're going to graph the first one. Okay, so let's say I have f of x is equal to x plus 2 squared minus 1. All right, so if our general formula is this, f of x is equal to a times x minus h squared plus k. Let's just identify every piece. Okay, if that's our basic, then our a value is the multiplier here, which is a 1. Our h value, this is a plus, that's a minus. So our h value is a negative 2. And our k value is a negative 1. Okay, so I've identified all of our pieces. Let's find the vertex. Well, the vertex is hk. It's going to be the point hk. So the vertex is equal to negative 2, negative 1, hk. Okay, the axis of symmetry is going to be the vertical line x equals h. And we have to have the x equals, so x equals whatever h equals, negative 2. Okay, we want to know how our graph opens. So this thing opens, it's either up or down, and we decide whether it opens up or down based on a. If a is a positive number, it opens up. If it's a negative number, it opens down. Our a value is positive 1, so this opens up. Okay? And the last thing is we're asked to find before graphing is whether the function is wider, narrower, or the same as the graph of f of x squared. F of x equals x squared, sorry. All right, so our a value is 1, so it is not between 0 and 1. It's not larger than 1. It is exactly equal to 1. So it's going to be exactly the same shape. Okay? Okay, so what this means for us is that this one is just a double shift, like what I mentioned earlier. Okay, because the number in front is a 1. I can still think of it as using this graph, and I'm going to make the vertex 2, negative 1. So if I move my vertex, which is this bottom part, to negative 2, negative 1, negative 2, negative 1 would be here. Okay, so my vertex is now negative 2, negative 1, so it's here. What did we think should happen? Well, h is negative, so that tells me it should be a shift left 2. This is a negative vertical shift, and this says I should go down 1, and that's exactly what happens when we move our vertex to here. So I have the point negative 2, negative 1, and then each of all the other points got shifted as well. This was my vertex, and I moved it left 2, down 1. Now I'm going to go ahead and ghost all my other points, and I'm going to move them accordingly. This point, left 2, down 1. Take this one, go left 2, down 1. Left 2, down 1. Left 2, down 1. And left 2, down 1. Okay, I need to do those in another color. I realized that was very confusing. Okay, so those are my new points. Connect them as smoothly as you can. And you have your new graph. Okay. Now, if you have a multiplier in front other than 1, you can't use your original 5 points, but if you know what to expect from your answer, you'll be that much better off. Okay, so let's just work these. We're just asked to identify what to expect. Okay, we want to find the vertex, axis of symmetry, how it opens, whether or not the function is wide or narrow or the same. okay? Let's identify our pieces. In this case, our A is 2. Our H, this is a minus sign, so our H is a positive 4. And our K value is negative 3. Okay? So, find the vertex. Well, our vertex is always the point HK. So this is 4, negative 3. Okay? Our axis of symmetry, which I'm just going to call the axis, is always x equals whatever your x equals here. X equals h, x equals 4. Okay? How does it open? We look at our A value for that. 2 is a positive number, so it opens up. Okay, now is this thing going to be wider, narrower, or the same? It again depends on our A value. A is 2. Okay, between 0 and 1. 2 is not between 0 and 1. 2 is larger than 1. And if it's larger than 1, our graph is going to be narrower. That's a lot we can tell just by looking at this. Even if after you start using a graphing calculator, you could know just by glancing at this basically what to expect. Your graph is going to be moved over to your vertex here. It's going to open up and it should be narrower than what x squared would look like. Okay, let's do our last one here. In this case, our A is equal to negative 1/2. Our H is equal to negative 1. And our K is equal to positive 3. So our vertex is the point HK, which is negative 1, positive 3. Our axis of symmetry is x equals h, which is always your x value here, x equals negative 1. Okay, now how does this open? We look at our A value for that. A is a negative number. That means it opens down. Okay, now we also use our A value to decide whether it's wider, narrower, or the same. In this case, we ignore the negative because each of these have absolute values in them. 1/2 is between 0 and 1, so this should be wider. Okay, and that's the end of this section.